stressing the notion of the uniformity of action potentials, and yet the way that action potentials can be used to pass that kind of information. Okay, so what we're going to do is we're going to have a little fleeing exercise here in terms of whether or not you flee. Okay, and you guys are playing the role of all of these neurons that are impinging on this cell body. Okay, and Sam, would you bring your green paper with you? Sam is going to be the neuron that either flees or doesn't flee. Okay, so stand right to front. So the decision to flee or not will be made by him, but he's taking the information from you guys, right? But he does not get to see that from which he might be fleeing. You guys see it. You're the sensory neurons that are sending the information back. He's tucked away safely in the brain, waiting for the information to come in, and then decides whether he flees or not. Okay? So the question is, do you flee? And he is a flee neuron. Flee with two E's, not the flee. You're a flee neuron. Okay? If you produce an action potential, then we're going to flee. If you produce a whole lot of action potentials, then we're really going to flee. Okay? But the decision as to whether or not an action potential is produced has to come from you guys. This is like an election. Think of it that way. And what you're doing is you're casting your vote for whether you flee or not. If you have a red piece of paper, that's the people on that side of the room. And it's kind of balanced in terms of the number of people. If you see a cue on the screen and you really don't care if he flees or not, you just leave your paper down. If you think that he should not flee, in other words, if you guys want to reduce the likelihood of flight, right? If you want to reduce the likelihood that he's going to produce an action potential, you hold your paper up, nice and broad, nice and bold, so that he can see it. If you think he really should not flee, right? Stay put, and like raise the paper and do some messing. Okay? The folks on this side of the room have green pieces of paper. Okay? If you don't care, just don't lift your paper up. So for everybody in the room, if you see a cue up here and you're like, okay, then just don't raise the paper. It doesn't matter what color you are. But if you think that he should flee, then raise the green paper. Okay? If you think he really needs to flee and get out of there, then raise the paper and like convince him that he has to flee. See what I'm saying? Does this make sense? Okay? What you're going to do, though, is you're not going to see the cue. Okay? What you see is this. You have to integrate all this information to determine whether or not you flee. If you decide you're going to flee, you raise the green paper. And if you think you have to flee a lot, you stick it up enthusiastically. Okay? That's your action potential. All right? Does this make sense? We'll do a couple of test ones first. Okay? A couple of test ones. And you can look at these. Okay? Do we flee? So here's a couple of green ones. Do you flee, yes or no? No. So you just leave the green paper down. Okay? Everybody good with this? You guys are really smart. They tried that? Well, okay. Yeah, good point. You just respond to the cue that's on the screen. It's true. Mom might be around somewhere and you don't want to be, but you're just responding to the cue on the screen. Okay? Your result is not to flee. Okay? You ready for the next one? This is the next test one. Okay? So you're incorporating all this information. All right? Now you face front and center, and you don't get to see these cues. You guys don't tell him what's on the screen. You're trying to convince him what to do based on what you do with your piece of paper. Okay, you ready? Yes or no? No. No, you don't. Okay, so no. Okay, you ready? You guys are like, yeah, whatever. Okay. An enthusiastic yes. Okay, you ready? No. Okay. Does not fire an action potential. the same response, though. It's not as enthusiastic as it was. I mean, show us again for this one. And then this one. Okay. Okay. Ready? No. You're going to make him flee? You're the screwed up neuron that had the rough childhood. Okay. Ready for the next one? That's fine. Yes, no? No. Okay. No fleeing. No, you're still not going to do it. That was interesting. It's kind of equally weighted. Okay. Ready? All righty then. Okay then. That's it, the hair. No. Okay. Okay. All right. Do you want to see what you had to go through? So that was almost a yes. That was most assuredly a yes. That was no. And then that was kind of no. And then that was confusion, except for the bad childhood neuron. And then we have this, of course. And then, what was the result on this one?
No.
No, okay. And then there's this one, and then this one, and then this one. And do you see the gradient that I put in there? We'll talk about that in a moment. And you definitely flee. And then here you don't flee, but you know. And then there you flee. Okay. Okay, you can sit down. But, all right, thank you. So, what I want to point out, though, there is sort of something that I want you to take away from this. All right. It's a fun exercise, but I do want you to note some things about it. You only had one color of paper, right? So you can only convey one opinion. What does that mean? As a neuron, you can only produce an inhibitory signal or an excitatory signal. As a neuron, you don't have a choice. You also are modulating that by what? By waving the paper quickly. That's the rate of action potential production. So the strength of that signal, right, is translated through the rate of action potential production. Now think mechanistically about how neurotransmitter is released into the synapse. There's a calcium flux, vesicles move to that presynaptic membrane, undergo exocytosis, and dump neurotransmitter into the cleft, right? One of the things we said at the end of the last lecture was, if you want to increase the probability of depolarizing the postsynaptic membrane, you produce more neurotransmitter. What's that mean? You dump more of those vesicles into that space. How do you do that? You have a whole bunch of action potentials coming down very quickly. They overwhelm the enzyme that's there, and you greatly increase the probability of depolarizing that membrane, or getting your neurotransmitter out, whether it's inhibitory or excitatory. Okay? So you only had the one piece of paper. So the thing I want you to note from this in this exercise, and thinking of how all this integration takes place, is each neuron can only produce one neurotransmitter. There are some exceptions. I talked to Dr. Liebel about this yesterday. There are some exceptions of nerves that can produce a couple of different kinds of neurotransmitters, but they tend to be either all inhibitory or all excitatory.